ready?
Yeah.
Hi, so this is Tracy. This is going to be part 2 of the experiment. It has to do with a half-wave rectifier. The idea is putting a diode in series with a resistor, or whether putting a diode in series with parallel capacitors or resistors. So in the first case, we'll look at a half-wave rectifier with a capacitor. So the idea here is that the voltage will send, deliver a current, but the diode would limit it to one direction. So when it goes through, there'll be charge stored in capacitor and through the resistor. And when we're using an AC current, so when it's in the opposite direction, it is unable to pass through the diode. So the capacitor is the one that provides the charge. Hence, when we look at the simulator, we do see that compensation, I guess, from the capacitor as we go into the opposite direction current in the AC current. And so that's it when we have a capacitor. And in the case that we, in the case that we don't have a capacitor, we'll see something like this. Because once the current passes through, it'll go through the resistor, but when the current is in the opposite direction, it is unable to pass through the diode, and so it doesn't go through, and that results in a flat 0 voltage on our results, which is very clear here. You can see that it stops right when it's going in opposite direction. Also note that there is some voltage decrease, and this is due to the inherent properties of the diode itself. And so when we actually tested this on a circuit board, we used the resistance with the actual resistance value of which is 9.808 kilo ohms, and we used the capacitor, the 0.1 microfarad capacitor. The actual value was 0.108 to 1 microfarad, which is extremely close. When we actually did the data, it was basically similar to what we expected. In the case of the 0.1 microfarad capacitor, the shape was pretty much equivalent. We see a similar kind of this is like a sawtooth wave, and for the half-wave rectifier without the capacitor, we also saw a similar result in our experimental data, which confirmed our model for a half-wave rectifier. And that's all for part 2.